Hello class, I hope you are doing well. Now today we continue with our topic trigonometry, and today actually we want to finalize on this topic. We want to look at application of trigonometry. We want to see how is trigonometry helpful in real life situation. There are some scenarios in real life that you will meet, and then trigonometry will come in very handy. Now, for example, sometimes you can see maybe there is an electricity pole, and sometimes you see there is a supporting string, a supporting wire. It is supporting that particular knee. When that wire was being placed, actually trigonometry was being used. There's a particular angle that the wire was placed, there's a particular length, and then there was a particular distance on the horizontal ground. So trigonometry basically, for example, if let's say you have been given the measurement, maybe you are standing on a horizontal ground, and then you are being asked maybe the distance between you, yourself there, and maybe a tower, and then this tower maybe a particular y meters. Then someone is asking you maybe at what angle will you be looking at to this tower for such that you can see the top part of the tower. Definitely, maybe the distance from yourself to the tower is known, the horizontal distance. You have the distance, then you need the height of the tower y. So using trigonometry, then definitely this is the tower, the horizontal ground is perpendicular. Definitely using trigonometry, there is a way you know how you will elevate yourself such that you will be able to see the top of that particular tower. Now this application actually you have been dealing with even in the previous lessons, is only that now we want now to see how do we analyze a given question. Now, and I want to use a question that is in KMF, a question that was set in the year 1994. You have a flag post, and in this question, the moment you have been given that word problem, it is important that you do an analysis of that particular question. Now you have a flag post 10 meters long. You have said a flag post 10 meters long is fixed on top of a tower. So we have a tower. So you come up with a tower. So this is our tower. And then they are saying that a flag post is fixed on top of that tower. So this is now this one is the flag post. That is the flag post, which is 10 meters. Then you are being asked, now you're being told from a point on horizontal ground, from a point. So this is the horizontal ground. So there is a particular point. From this point, the angles of elevation of the top, and from one, we talked about angle of elevation and angle of depression. So if let's say for example this is the horizontal ground, you elevate yourself in that particular direction. So that will be the angle of elevation. Maybe if you are somewhere here and then your eyes are fixed horizontally, the angle of depression is when you move like your head downwards. So that one becomes your angle of depression. So they are saying the angles of elevation of the top and bottom of the flag post. The top and the bottom of the flag post. So the top, we have the angle of elevation of the top being 40 degrees, and then from the same point, the angle of elevation of the bottom, so from this point here we have 33 degrees. Then you are being asked to get the height of the tower. So if this one we've said it is a perpendicular to the horizontal distance. So if you are getting the height of the tower, let the height of the tower maybe be x meters. You have this angle, and you have the whole of that angle, the whole of this being 40 degrees. So if we can apply trigonometry, we want to see, let's say for example, the representation of that particular side. Now we have this side as x meters. So we can say, okay, let's say this is the horizontal distance, this one, let's call it y. So this is opposite and then adjacent. So tan 33 degrees will be equal to x over y, opposite of adjacent, that's tan 33 degrees. Then we try and see again. Now the whole of this is will be x plus 10, the 10 and the x meters. So we can be looking at this particular triangle. Remember, the whole of that angle is 40 degrees. So tan 40 degrees is equal to opposite. Now the opposite will be the whole of this, which is x plus 10, then divided by that adjacent y. So in this case, y is equals to x over tan 33 degrees. In this case, y is equals to x plus 10 over tan 40 degrees. Now remember, when this is y, meaning they are the same. So we can equate. So we can say x over tan 33 degrees is equals to x plus 10 over tan 40 degrees. Now from this point, actually whatever you will get for the value of x, is what now you are being asked as the height of the tower. So I expect that you will go and check the tan of 33 degrees from the table. You will go and check the tan of 40 degrees from the table, do the substitution here, and I will like you to get the value of x. The value of x will be the height of the tower in meters. Then you are being asked part B, the shortest distance from the point of the ground, shortest distance from the point on the ground, to the top of the flag post. So the shortest distance from the point on the ground. The point on the ground, you have that point here on the ground. So they want from this point to the top. So actually this is what they want. Now if you've gotten the value of x here, you can substitute and get this value from here to here. Then you can go back and substitute to get for the value of y, and then you can just use Pythagoras theorem to get this, or you can still use trigonometry because you'll be having this part, and then you have this, you have the angles there. You can get this side as the shortest distance from the point to the top of the flag. So basically, in application, it is important to do an analysis of the given question and try and break it down and see how trigonometry, the ratios, trigonometric ratios will help you achieve maybe the asked parts. I expect that you will go to KMF and even KLB and do more exercise on the application of trigonometry. We've done one example. If there will be any challenge, we will tackle. Thank you and have a blessed time.